one car has a mass of 1.4 times 3 kilograms and is traveling at 4.5 kilometers south. The other car's mass is 1.2 times 3 kilograms. And they're completely inelastic. Okay. Number 3. Alright, so we've got one car which is traveling south. So that vector represents the southward car. We've got another one that's traveling east. Okay, so we've got two objects, A, B. They collide at some point, and the one that's going, it's got a bit more mass. I'm not sure what it's going to look like, but let's say that they end up moving off in this direction, and they're stuck together. So there's our basic collision problem. So they come in 90 degrees to each other, and then they're stuck together. So what do we know? We know the mass of A, we know the mass of B, and we have to find, we know the velocity of A, the velocity of B, and we have to find their velocity just after they collide, which we're just going to call B prime. Okay, inelastic collision means we don't have conservation of kinetic energy, so we're not going to worry about kinetic energy in this case. So we just have conservation of the total momentum of the system. So total momentum before equals total momentum after, so P equals P prime. Momentum is a vector, and we've got a 2D problem here, so we're really looking at 2 dimensions. So we're going to have sum of the momenta in the x before equals sum of the momenta in the x after. And we also have sum of the momenta in the y equals sum of momenta in the y after. So here's our 2 equations we're going to expand out. We're looking for maybe 2 unknowns. We're really looking for the 1 unknown here, though. All right, so let's look at our x. So before the collision, the system has an x component of momentum. Well, B's got an x component of momentum, but A's got no x component of momentum. So we can write it like this. Say PAX plus PAY. That's going to equal PAX prime plus PAY prime. The sum of momentum before equals the sum of momentum after. Y's got no momentum. Wait, no, I don't want that. This is BX. This is my bad. And after they both got some component of x. In fact, after they're just a single object. So we can say NA VA equals, and that will just be the momentum of a single object, which has a mass of A plus B. So mass A plus mass B times B prime. Oh yeah, sorry, it was late at night last night. Kids. Don't was on YouTube.
Then PAX is 0 and PBX is on your first one.
Yeah, that's 0. Thank you. Okay, am I good now?
Yeah.
All right. Okay, so we've got B is the only one with an x component. So we've got an x component of B's momentum, and that's going to equal the x component. That's going to equal the x component of this momentum after. All right, let's look at the y now. So in the y, and of course, with these sorts of questions, we always define our positive, negative directions. So now for the y, we've got the same thing. So momentum of A in the y plus momentum of B in the y equals momentum of A in the y prime plus momentum of B in the y prime. So this time B has got no momentum in the y, so this is the one where B goes to 0. So we've got mass of A, velocity of A in the y, and this is going to equal the momentum of this, the y component of the momentum of this system after the 2 objects stick together. So MA plus MB plus B prime y. So So the other way to look at it is that you've got these two components of the momentum. So that this one gives us this component, this one gives us this component. It has to. Yeah.
Pretty much just a vector addition.
Yeah, it's just a straight vector addition. I'm showing you a general method though, because when you get to more complicated ones where it's not 90 degrees, it's nice to have your equations. Okay, so now let's look at what we know here. We're given the mass, we're given that velocity, we're given that, we're given that. So we can actually just solve for that right off the bat. Here we're given that mass, we're given the initial velocity of the y of A, which is VAY, then the two masses, so we can solve. And once we've got these two components, it's going to give us a triangle that looks something like this, where this is Vx prime, this is Vy prime, this is V prime. So you want to use Pythagorean theorem to find this. And then you can use inverse tangent to find that. And that's what they want to know. They want to know the final velocity. Okay, so basically all your momentum style problems, 2D problems, they follow this same idea. You've got two objects colliding, so find the sum of the x momenta before, that'll equal the sum of the x momenta after. Find the sum of the y momenta before, that will equal the sum of the y momenta after. Get yourself two equations. This is a two equations, two unknown situation. This was a pretty easy one because we could solve for each equation for a value. But in other ones, you may not be able to do that. And in this case, we had to find that v prime.
What question
Pythagorean
is
theorem.
this?
This is question number 3, page 257. Question?
Well, I was just saying, you can do Pythagorean this right off the bat.
Yeah, there's simpler ways to do it. So for this
That's
one,
that's what I did.
yeah, so for this one, since you had the x and y momentum, the x and y components of the momentum, and by reasoning through it, you can see that this equals that, and that equals that, right? So right off the bat, you know these two components. Use Pythagorean theorem on your momentum vectors. Find your final momentum, divide it by the sum of n A plus nb. You've got yourself your final velocity vector.